So we continue with interpreting a z-score. Just remember that a z-score is a standardized distance that some observation is from the overall mean. Now, like the previous example, I'm not going to go ahead and draw a distribution. There's a lot going on here. Now that we have an understanding of what z-scores mean, how we can interpret them. So I'm just going to read this example. It says, the Mount Marathon race is held every 4th of July on Mount Marathon in Seward, Alaska. It is a dangerous and brutal 5-kilometer foot race to the top of Mount Marathon and back to the start. In 2020, for the men's division, Bryant had a winning finish of 42.9167 minutes. For the women's division, Charlotte had a winning finish of 53.3333 minutes. The finish times for all men are approximately normal with a mean of 73.0352 minutes and a standard deviation of 18.0108 minutes. The finish times for all women are approximately normal with a mean of 89.406 minutes and a standard deviation of 19.4678 minutes. And of course, the big question is, relative to their peers, who had the faster finish time, Bryant or Charlotte? So as we look through here, here's Bryant. He had a winning time of 42.9167 minutes. So I'm just going to put down Bryant over here. And his time, that's X, is equal to 42.9167. For Charlotte, I'm going to put Charlotte over here. She had a winning time of 53.3333 minutes. So her X is 53.3333 minutes. Now it says that the finish times for all men. So since this is a population. We're talking about every man that ran the race in 2020. So the finish time for all men, that's our population, are approximately normal. So it makes a normal distribution, a normal curve, with a mean of 73.0352. So I'm going to put down a mean here. 73.0352. And a standard deviation of 18.0108 minutes. So sigma is equal to 18.0108. The finish time for all women, there's a population again. Here's our all. That's every woman that ran the race in 2020 at Mount Marathon. The mean for all women was 89.406. So that means there was a mean for the women, 89.406, and a standard deviation of 19. Sigma is equal to 19.4678. So as you can see here, the average time for the men was 73.0352 minutes. Brian is well below that. He ran a little less than 43 minutes. So his z-score is going to be well below the average here, which is good because when you run a race, you want to be further below the average. If you're below the average, you're running a faster race, and he's well below the average. Same way over here for Charlotte. The overall average for the women was 89.406 minutes, and she's below that average, so she ran a very fast race too. Of course, we want to determine relative to their peers who ran the faster race. Well, the way to do that is to be able to determine their z-scores. Whoever has a z-score further below the average ran the faster race. So for Bryant, we have 42.9167 minus the mean of 73.0352. Then, of course, we will divide that by the standard deviation 18.0108. This is negative 30. 0.1185. So then Bryant had a z-score of negative 1.6722. So he was 1.6722 standard deviations below the average. That's pretty far below the average. He ran a very fast race. And we'll do the same for Charlotte. 53.3333 minus the mean of 89.406. Divide that by the standard deviation. That's negative 36.0727. That's a z-score. Charlotte's z-score is approximately negative 1.8529. So she is 1.8529 standard deviations below the average. So she ran a very fast race too. But since she is further below the average than Bryant, then Charlotte ran a faster race according to her peers.